Hello guys, so today I'll be solving this problem, which is maximum subarray sum with length divisible by k. So the problem states that we have been given an integer array nums and an integer k, and we have to return the maximum sum of the subarray, okay, of nums. Okay, so we have to return the maximum sum, okay, of a subarray. Okay, so that's our goal. Now there is a condition over the subarray, is that the length of the subarray, okay, such that maybe for all length of the subarray, it should be divisible by k. Okay, so yeah, we have to find a subarray sum. Okay, and that subarray sum needs to be divisible by k, or the subarray length should be divisible by k, and we need to maximize that subarray sum. Okay, so yeah, that's the goal. Now how to solve it? So if we simply forget about all the constraint, okay, a naive brute force solution will be we can use three nested for loops. Okay, so one for loop maybe I to 0 to n, another for loop will be I plus 1 to n. Okay, now I am fixating two pointers at every indices. Now for each of this, now this will give me the pointers for start and end for every subarrays. Okay, now in order to get the sum, or maybe I can have a condition. So length, I can check, length will be j minus I plus 1. So this will be length of the subarray. Now I can check, like, if my length is divisible by k, okay, I will try to find the sum. Now in order to find the sum, I will be needing another for loop, okay, which will be, let's say, k, starting with I to j. Okay, so j inclusive, so I can say j plus 1. Okay, so yeah, here I'll be doing the sum calculation, and after that, let's say I have some global answer variable, okay, that I will be updating with sum of max, and or maybe something like this. So here I'll be finding the sum, which is like 0. I'll be saying sum plus equal to my nums of I, and at the end of this for loop I'll be updating my answer to max of ans and sum. Okay, so this is the naive brute force approach. Now if you look at the time complexity, so we have a quadratic time complexity for finding the subarrays or iterating over all subarrays. Then in order to find the sum of the subarray, we are again having a for loop which will bring our quadratic to cubic time complexity. Okay, and at the end all of them are like constant time complexity operations. So yeah, with this brute force approach we'll be doing a big O of n cube kind of a solution. Okay, now in order to get rid of this for loop, we can use the help of prefix-sum. Okay, so those of you who don't know about prefix-sum, you can simply search for it. Okay, you can read about some article, but yeah, the idea behind prefix-sum is, so if you want to find the subarray sum very quickly or maybe in constant time, okay, then so this is for like calculating the sum of a subarray. Okay, so if you want to find the sum of the subarray in constant time, then you will be using prefix-sum. Now once we have a prefix-sum here, then we can get rid of this. Okay, and by the help of prefix-sum, now our time complexity will reduce down to big O of n square. Okay, so yeah, now we have reduced down to big O of n square, but if I look at the constraint, okay, my length is varying between 1 to 2 times 10 to the power 5. So n square will bring 10 to the power 5 to 10 to the power square, so I will get a happy TLE. Okay, now how can we do something better here? Okay, so far we have been naively satisfying this condition using brute force. Okay, let's think of a way to optimize this condition. Okay, how can we smartly detect which indices to pick? Now let's do some maths here. Okay, so how do we define length there? Okay, so we define length by j minus I plus 1. Okay, so if I defined my length as j minus I plus 1, and I know in order to satisfy, or in order to even nominate a subarray, okay, to get into the calculation for sum, that subarray length needs to be divisible by k. Okay, so if I do it here, and now if I bring j minus I plus 1 to this calculation, so this will look like j minus I plus 1 mod k, it should be equal to 0. Okay, now let's do a distributive arithmetic here. So I will say j mod k, okay, minus I mod k, okay, plus 1 mod k, it should be equal to 0. Okay, now let's do a little bit modification here. So I can say j mod k, okay, needs to be equal to I mod k minus 1 mod k. Okay, so yeah, now if we simply consider, let's say, k to be greater than 1, okay, then this condition will simply fall into j mod k equal to I mod k minus 1. So what does this imply? So this imply that if I have a ith index, okay, now if I take the modulus, or if I divide that ith in I with k, whatever remainder I am getting, okay, so, and after that, after I'm done with the remainder calculation, if I do a minus 1, okay, then whatever remainder I'm getting, okay, so after I, whatever whatever indices are giving the same remainder, okay, those will automatically qualify, or those subarray present between I to that index, which is like j here, okay, those will automatically satisfy my subarray condition. Okay, so we can maybe take an example here. Okay, so for example, let's say I have let's say a1, a2, a3, a4, a5, a6, a7, a8, a9, and a10. Okay, so I have written down the indices. Okay, now let's do a uh, remain remainder calculation for those indices, and let's say my k is maybe 3. Okay, so if k is 3, okay, for 1 the remainder will come as 1, for 2 the remainder will come as 2, for 3 it will come as 0, for 4 it will come as 1, for 5 it will come as 2, similarly for 6 it is 0, 7, 1, 8, 2, 9, 0, and for 10 I have 1. Okay, so let's say I want to know for this a4 guy, okay, which index should I select as my right point, so that if I am starting with starting a subarray from a4, okay, where should I end such that my subarray length condition will satisfy. So as per this math condition, it says that for a4 the remainder is 1, so my required next mod, okay, should be 1 minus 1, which is 0. So whatever indices are giving me 0 value, those will be qualified, okay, for my those will like satisfy my subarray condition. So for example here I have a6 as my 0. Okay, now if I look at the subarray between let's take a different color, between a4 to a6, okay, I can clearly see there are 3 elements, or my length of my subarray is 3, which is a multiple of my k, so it is satisfying. Now another 0 I am seeing is at a9. Okay, now if I take this subarray from a4 to a9, okay, and I calculate the number of elements. So here I have 1 2 3 4 5 6 6. 6 is again a multiple of k, which means this subarray will qualify to be for, like, will get qualified to be for my maximum sub calculation. So yeah, with this um, relation I can uh, like find out what all indices I need to capture, okay, or for a particular index what next index should I look, okay. Now another fact, if you observe, so whatever my next uh, or my whatever my indices, okay, are satisfying my required next mod condition, okay, those are basically just before the or like just before those indices which are same as my starting index, okay. So for example here a4 is 1, okay. So if I look at the index which is having the same mod, which is a7 here, okay, now just before a7 I'm getting a6, okay, which is satisfying my next required mod condition. Similarly for a4, again for a4 the remainder is 1, so the after a7 I have a10, okay. Now just before a10, okay, I'm having a9, which is satisfying my next mod condition, okay. So that means if I have a mechanism where I can group out those indices based on mod values. So what I'm saying is, so here if I look my mod values, so I have mod zeros, okay, or like the remainder zeros, I have remainder ones, I have remainder twos, okay. Now what all indices are satisfying my zero modulus value? So a3, okay, a6, okay, and a9, a9. For a1 if I look, a1 is there, a4 is there, a7 is there, a10 is there. Similarly for a2 I for remainder 2 I have a2, then I have a5, then I have a8, and like that, okay. So if I see, okay, so uh, maybe I can create one more here, a2, a3, a4, a5, a6, a7, a8, a9, and a10, okay. So if I look at a3 to a6 subarray, okay, so the number of elements that I'm having, okay, it's basically my required number of elements plus 1 here, which means I can either neglect this guy, okay, or I can neglect this guy, okay. So if I neglect one of those guys from the end, whatever remaining elements I'm having, those elements, or like this the remaining subarray I'm getting, that length of that subarray will automatically satisfy my subarray condition, which is like it should be divisible by k. So yeah, that's the idea here in order to choose the subarrays. Now you may ask, hey, okay, I have grouped the indices which are having the same mod value, okay. So do I need to like iterate over all those indices, okay. So maybe for this case, do I need to iterate over maybe I 3 6 9, okay. Now let's say I have a j, again 3 6 9. I can have a case if I is less than j, okay. I will do the calculation of the subarray sum maybe using prefix, okay. I will say my ans will be prefix of j minus prefix of I, something like that. So from this I can go with this approach, so this will give me result, okay, because whatever indices I'm choosing from this group, those indices will always satisfy my length condition. Okay, now if I go in this approach, this is again giving me a quadratic time complexity. Okay, now we did all this to get reduce, or like to reduce the quadratic time complexity. Okay, but even after grouping, we are still not able to like optimize it more. Okay, we have an intuition of grouping and all that, but how to use it? Okay, or how to get rid of quadratic time complexity also. Okay, now this is where uh, prefix calculation will come into play. Okay, so let's see. So what we are doing it here is we are generating a sum. Okay, a sum of the subarray, right? Our final goal is to maximize the subarray sum, right? That means this prefix calculation needs to get maximized. Now how can we do that? Okay, so if I look at prefix of j minus prefix of I, so this is a subtraction kind of a calculation, right? So when you have a subtraction kind of a calculation, you have two choices. Okay, either you can fix it this value. Okay, if I fix this value, then I only need to take care of this, which means I need to increase this guy only. Okay, or you can fixate this guy, okay, and try to reduce this value. Okay, now use going via this approach, this will be lot easier to do. Okay, why? You can like ask why. Because what we will be doing is we will be traversing over the array from left to right. Okay, which means we will be getting we can calculate the remainder values on the fly for every indexes. Also we can calculate the prefix value also, which means like a1 plus a2, a1 plus uh, a2 plus a3, like that. Okay, finally I equal to 1 10 a of I in the end. So if we go from left to right, okay, we can easily calculate the index mods, okay, as well as this prefix values. Okay, now if I have a mechanism, okay, or if I have a tool that can tell me, let's say if I'm at a ith index where my prefix calculation is giving me a1 a2 up to a of I. Okay, now for this guy, okay, or for my ith index, okay, I'm getting a modulus of this value, okay, I mod k. Then for this prefix, what is my minimum prefix I have gotten, okay, which is satisfying my remainder calculation to my left, which is like in this zone. Okay, so what I'm saying is, so for let's say for some ith element here, okay, the prefix array will look something like this. Okay, a1 plus a2 plus a2 plus a3. Okay, and for my ith index, the prefix value will look something like this. Okay, now for my ith index, if my remainder is this. Okay, now if I ask a question, okay, let's say if I have seen the remainder before coming to ith index. Okay, now from this strategy I know if I have seen a value, okay, or if I have seen an index whose mod value is same as what mod value I'm getting currently, okay, then I'm already satisfying, or I have a subarray whose length is satisfying my divisibility condition. Okay, then from the left, if I'm storing the minimum prefix calculation, okay, let's say on the left I have some maybe k index, such that the prefix calculation for it is like a1, a2 up to ak. Okay, so here I'm saying k is less than I. Okay, and k mod of, or let's not take k, okay, because k is a remainder or my condition here. Let's say maybe m. Okay, let's say m is there. So I'm saying, let's say there is a m index which is left to my I. Okay, and the prefix calculation for m will look like a1 a2 summation to till m, and m is less than equal to I, and m mod of k is equal to my I mod k. Okay, so if I know that, okay, for some m index on the left, okay, like from the left, uh, for some m index I'm getting the minimum prefix value. Okay, minimum prefix value for this remainder. Okay, then I can subtract this value for my current prefix. Now if I subtract the minimum prefix value for my current prefix, then I will be maximizing the subarray calculation as per like this logic. Okay, because right now in every iteration I'm kind of getting new prefixes values. Okay, now for every ith index I'm getting new prefix value. Now for those ith index I can easily calculate the mod value. Okay, now on the left, if I check for the same mod value, do I have an index? Okay, and does that index have a prefix-sum lesser than, okay, or maybe the least for that mod value, then I can use that prefix calculation. Okay, and I can subtract that prefix-sum, okay, or the minimum prefix-sum with the current prefix that I'm getting. So yeah, that's the idea behind the question. Okay, uh, maybe if I run a test case, you guys will have more clarity. So I'll start with simple. Maybe I can take this. Okay, so let's say -5, 1, 2, -3, and I have a 4 here. Okay, now let's quickly assign the indexes. Let's say this is 0, this is 1, this is 2, this is 3, this is 4. Okay, now let's quickly do the index mod of k. Okay, or the index remainders. So here k is 2. Okay, now if I do the remainder calculation, so 0 mod 2 is 0, and this guy will give me 1, this guy will give me 0, and 3 mod 2 is 1, and 4 mod 2 is 0. Okay, and let's do the prefix calculation also. Okay, so for -5, so yeah, -5, then -5 plus 1, this is -4, then -4 plus 2, it is -2, then -2 -3, it is -5, then -5 plus 4, it is -1. So yeah, this is how my prefix will look. Okay, now if I check, okay, now if I check, okay, so if I go from left to right now, okay, yeah, maybe not like this. Okay, so this is something I'm showing. Okay, this is something I'm showing to you guys. Okay, how the final prefix will look, but when we will be doing it, we will be doing it in one for loop. Okay, so we will be calculating the prefix on the fly, and at that time we will be checking. So here in this case, so let's say I have a math, okay, or maybe a table kind of thing, where I'm storing my I mod k, and the least prefix for that remainder. Okay, let's say this is my remainder, and here is the least prefix. Okay, uh, for that remainder. Okay, let's see, or maybe I will write it like this, least prefix simply. Okay, cool. So I started with this guy -5. Okay, so for -5 I'm seeing the remainder is 0. Okay, right now my table doesn't have an entry for 0. Okay, so I will simply put an entry here. I'll say for 0 remainder, so the least prefix that I'm getting is -5. Okay, cool. Now I'm at this index. Okay, now for this index my prefix went to -4. Okay, now I'm checking what is the index, or what's the index mod k I'm getting. Okay, what's the remainder value? So I'm getting 1. Then I will look into the table. Do I have a value for 1 here? Okay, no. So I will put this, or I will register this value. So I will say 1, and the prefix I have gotten till now, let's say that to be -4. Okay, then I will be at this index. Okay, now if I see, so for 2 my prefix is -2 now. Okay, now if I check the modulus for this index, okay, that is 0 here. Okay, now I'll look into the table. Okay, so do we have a prefix? Okay, so what is the least prefix I have gotten for this mod value, which is 0? So I have gotten -5. Okay, right now if I look, my prefix is -2. Okay, which basically means I have an index. Okay, I have an index to the left of this guy that is having the same remainder as my current remainder. Okay, now I will check whether now I will check the least prefix that I have gotten. So for this guy the prefix was -5. Now for my current, my prefix is -2. So I can update my answer. Let's say I have an answer variable, so I can update my answer variable to -2 minus of -5. So this will be 3. Okay, cool. Now my answer is updated to 3 now. Now I'll check. So I have gotten this answer, but now I need to update my prefix table. I will check for this index. This was the mod, but the prefix that I'm getting, is it lesser than what I got earlier? Nope. So I will not update this table. Okay, then I will move to the next index, which is -3. Okay, so for -3 I'm seeing the remainder is 1. Okay, and my current prefix is -5. Now I'll check in the table. Okay, do I have a prefix, or do I have uh, a value for a remainder 1? Okay, because if I have it, then that means I have a least prefix that I have gotten. So I'm getting 1 here. So for 1 I have already gotten -4. Okay, so -4 is my least prefix. Okay, so what I will say is, I will do the, so that means first I'm getting a value which is having the same modulus. Okay, that I have previously encountered. That means whatever left value I have gotten earlier and whatever value I'm getting. Okay, if I do a subarray, their length will automatically satisfy my subarray length condition. Okay, so now for that index, what's the least prefix I'm getting? So that is -4. Okay, now here the prefix is -5. So if I do the sum, okay, the sum of the subarray, that will be -5 minus of -4, and this will give me -1. Now I will say -1 is -1 like more than the current answer that I have? Nope. So I will not update my answer. Okay, now I will say, okay, so for this remainder, okay, do I need to update my table? Okay, so for this remainder, now I have a -5 value. Now in the table I have a -4. Okay, so I can update my -4 with -5. Okay, for this guy, because now -5 has become the least prefix for this remainder, okay, or for this modulus. Okay, then finally I will be at this iteration. Now at this iteration I will see that the remainder is 0 and my current prefix value is -1. Okay, now I'll check in the table what is the minimum value I have gotten for this modulus, that is -5. Now I will do the sum calculation. Okay, so for this index I'm getting -1. Now the least prefix that I have gotten for this remainder, it is -5. So I'll do a minus of -5, it will be 4. Okay, now I'll check, is 4 is more than my answer? Yes. So I will update my answer, maybe like this, to 4. Okay, now after this I do not have any element, and finally my answer has updated to 4. Now if I check the answer, my answer is 4. Okay, cool. So that's the idea. So just store the minimum prefix value that you have gotten for the index remainder. Now as you keep on iterating from left to right, you can use that least prefix value in order to get your current, or in order to maximize your current subarray summation. So yeah, I'll be first doing for C++. So let's first create a alias for long. So I'll say ll long, and I can move this value to ll. Okay, so first I will create my answer variable, and I will initialize to a very less value because I need to maximize my answer. So let's say long mean, long mean. Then I need to create my prefix variable. Okay, so I'll say ll prefix. Okay, let's say I will initialize to 0. Okay, then I'll create an array that will store for every modulus, okay, the least prefix value that I have gotten. Okay, now if you check the index mod k, what's the range of this function? Okay, this is between 0 to k minus 1. So I can simply create a vector of size k. Okay, and I can call it finder. Okay, and at first I will so since I'm using a vector, so they will be pre-initialized with 0, but it may happen my least prefixes are lesser than 0, so I need a more more negative value. Okay, because I cannot initialize with 0. So I can see that my nums of I are varying between minus 10 to the power 9. So maybe I can create a very large negative value. So I can create, let's say let's make it ll. So I'll say, let's say I'll call it unset, and I will say let's say -2e9. Okay, I will say unset. Now if for my current modulus the value is like unset, I will simply say that I haven't got any prefixes for that modulus. So yeah, that's how I will be using it. Now I'll be iterating over all the values. Okay, so I'll say for I in range, or maybe I will start with like the way we are doing with doing prefix calculation. So I will start with I equal to 1, I will go with I less than equal to n, I plus plus this, then I will create n as my num size. Okay, then also one more thing we need to take care of this. So if I look at here, okay, so finder of this and this. Okay, now here we are missing out a value. Okay, so the reason for me to start with 1 here is because if we look at the prefix calculation, okay, so when you have like a1 a2 a2 a3 like that up to an, okay, so your prefix of your last value, okay, of n that basically gives you the summation of all the values. Okay, so in prefix calculation, when you are doing like when you are finally doing the subarray calculation, it may happen you are getting the whole array as your subarray. Okay, it may happen. Okay, so in that case you need to create a null index here. Okay, and generally that null index signifies that a naught. Okay, so generally this is the way we do prefix calculation. So we have a null value because when we create our prefix array, we create it n plus 1. Okay, not exactly n, because we can do it with n, but there will be other condition you need to take care of it, like when you are doing like prefix of r minus prefix of l, your l you were doing l minus 1. Now that l minus 1 should not be equal to like lesser than 0. So yeah, for that it's better to like always initialize your prefix with n plus 1 elements and have the null set, or like not the null value at prefix of 0th index. So similarly here what I'll be doing is I'll be saying like finder of 0 is 0. Okay, now why I did that? Because finder of 0, if I'm saying, so when I'm considering my prefix based indices, because I'm iterating from 1 to n, okay, this is my prefix based indices. So for that, my 0th element, okay, so for my 0th element, the remainder is 0 mod k, okay, which is 0. Okay, so at that place I do not have a prefix. Okay, basically I do not have any element, so for that I'll be setting it to 0. So yeah, then yeah, this is the prefix calculation. Then I will be doing the index mod, so let's call it mod. So I'll be saying I mod k, then I'll be updating my prefix count, so that will be like my prefix sum, that will be nums of I minus 1. Okay, then I'll be checking if my finder of my mod has gotten a minimum prefix value, okay, or it hasn't. Okay, that means if it is equal to unset, okay, if it is not set, then I will set my current mod value to my current prefix value, then I will simply continue from that. Okay, otherwise I'll update my answer to max of answer and my current prefix minus the least prefix that I have got for this mod. Okay, then after that I'll be updating my mod with the current prefix. Okay, and finally I'll be returning answer. Cool, and I have gotten wrong results. Okay, everyone is like off by 1. So let's see, what could be the reason. I've initialized to 0, and this is this, and this is mod of this value. I'm doing this, Einstein is correct, and this value that is I mod k, that's the remainder. This prefix calculation if not set, I'm initialized, yeah, if this is not set, I'm initializing to pre and continuing from that. Answer should be good. Then my main guess would be I'm doing something wrong here maybe during this initialization. So finder of 0, that should be 0, because that defines my null index. Now in that null index I have no element, which basically means the sum is 0, right? Yeah. What could be the reason? Yeah, as a silly mistake, so I'm directly assigning my finder of mod to pre. I need to check, I need to store the minimum of that, right? So that should be finder of mod of pre. So yeah, if I run this, it should work. Then if I submit, Yeah, cool. It got accepted. So yeah, if I look at the time complexity, so this is like uh, big O of n, and because I'm touching every element once, okay, and after that all of them are like constant operation. Now the space complexity will be big O of k, which is the division number. Cool. And yeah, let's quickly do it for Go. So I'll be creating my answer. So var ans int 64, and that I'll be initializing with the very negative number. So for that I will be using math. So here I'll be saying uh, math dot min int 64. Then I'll be creating my prefix. I will initializing it to in 64, and with that it will be initialized to 0. Then I will need to create my finder, which is make of int array of int 64, and that I'll be initializing with k. And yeah, I need to set all the values to unset. So I'll create my unset. So I'll say unset, it will be int 64, and this will be minus 2 e9. Okay, and I'll be updating all the values for my finder. So I'll say finder this colon range of finder. I'll say finder of I equal to my unset. And yeah, after that let's capture the length of the array, so that is nums. And yeah, one more thing, so finder of 0 will be 0 as per this logic. Yeah, cool. Now I'll be iterating over all the elements. So for I this to this, I less than I will start with 1. It's like prefix calculation. So I'll say this. Now I will calculate the mod. So mod will be I mod k. Then I will update my prefix sum. That will be nums of I minus 1. Then I'll be checking if my finder of mod is equal to unset. So this is pretty identical to C++. So here I will say mod of this is equal to pre, and I will continue. Okay, if this was unset. Otherwise, I will update my answer to max of ans of current prefix minus whatever minimum prefix I have gotten for this mod, and I'll rate my mod finder of my mod's least prefix to be minimum of finder of mod minus whatever prefix I have gotten. So yeah, and after this I will return my answers. Cool. Sweet little error. So yeah, now this is like int. I need to convert it into int 64. So int of 64. If I run this, yeah, oh, yeah, it's 64. Yeah, passed. Cool. Now let's finally do it for Rust. Now for Rust, I will be creating my answer. It will be a mutable type, and I will be initializing to a very minimum number. So that will be I64 main. Then I will be creating my prefix, and that I'll be setting to 0. And here I can say like as I64, so it will be automatically initialized to I64 variable. Then I need to create my finder data. So I'll say let mut of finder. So here I will say it should be a vector of size 64, vector of I64 data type. Then here I will initialize my vector to be of size to be of, I need to give the default value that is unset, and this is of size k, and this needs to be of usize. Then I'll create my unset. So I'll say unset equal to, so I can use something like this to e9, and here I will say as I64. Cool. Now this will be initialized to this. Cool. Now finally I will store the length, which is like nums of length. Then I will iterate over all the elements, which is I in range 1 to n. N. Then yeah, after that I will first calculate the mod. So mod is a reserved keyword, so I will use in capital mod. So here I will say I mod k. Cool. Now I is use size, k is I32. Okay, and then later on we will be using mod as indices, which means basically means I need to convert it into u size. So here I can say like k as u size. Okay, and after this I will be updating my prefix-sum, which is like nums of I minus 1. Now this I need to say like as I64 because my nums are like in I32 format. Okay, cool. Now I'll check if finder of my mod is equal to unset. Okay, so which basically means for this current modulus I haven't found the least prefix or any prefix. Okay, so I'll update my finder of mod to the current prefix that I have gotten, and then I will continue from that. Okay, then I will update my answer to yeah, I need to use max, so I will use std comp. Then I will say comp of max of ans with then I will calculate the Subarray sum, which is like 3 minus finder of mod, and I'll update my finder of mod to comp of mean of my finder of mod with the current prefix. Okay, cool. Then finally after all this I will return my answer. If I run this, it throws me error because finder of mod is I60 mod. Oh yeah, it's a reserved keyword. Yeah, it should be capital mod. Cool. Now if I run this, yeah, here I haven't set the finder condition, so yeah, I'll say finder of 0 is equal to 0. Yeah, because for this case it needs to get all the whole sum. So yeah, for that I need to set finder of 0 to 0, otherwise it is fixating to this element only. So yeah, I'll run this. Now all test case passed. Now if I submit, cool. All 3 solutions and all got passed. So yeah, this was the key idea behind it. So you can start with brute force solution, but after that you will start reducing the time complexity using different algorithms. So don't just stop at prefix. Okay, just try to get the analogy behind the actual condition, which is like on the subarray length. From that you can do this little math, and from that you can get the relation between the indices. And once you find the relation, then you can maybe run some examples in your copy or something. Then you can see that pattern between like the between same indices. Now with the same indices you are getting the length validation already. Now how to get the least prefix or like the least prefix sum, and why to get the least prefix sum? Because we need to maximize the sum subarray sum. So yeah, so yeah, that's the idea. So I hope you learned something new. So if you like the explanation and the code, so please do like and subscribe the channel. That will motivate me to make more videos. So yeah, stay tuned to watch more videos. Bye bye.